Okay, so lesson 52 is on polar equations and conic sections. So polar equations can be used to graph conic sections. Conic sections, as you guys know, are parabolas, hyperbolas, ellipse equations, and circles, right? So we can have these all in polar equations. So the general polar equation for a conic section with one focus at the pole, so that's kind of weird. I'm talking about one focus being at the pole, is r equals k over a plus b cosine theta and r equals k over a plus b sine of theta. All right, basically every single conic section, do you guys remember how we had like the parabola had a directrix and a focus? Every conic section actually has something called a directrix and a focus. Now, I'm not really going to go into detail about where the directrix is and where the focus is on a lot of these. We're just going to sketch these out. We're going to keep it very, very simple for this section, okay? So if you ever are curious about that, you can read into it, but it is all about distances, right? Conic sections are all about distances. So, okay, so on your test, you will have these two equations, and you'll have this little thing that says if absolute value of b is less than absolute value of a, then the graph is an ellipse, right? So you're kind of going through all these different things. In order to find this, we're going to use something called eccentricity, okay? So eccentricity is going to be E equals the absolute value of b over a. So you might have seen the word eccentricity before for an ellipse. It basically talked about how circular it was, okay? So basically if we had something that was really, really wide versus something that was really circular, the eccentricity was different in Algebra 2, right? One of them was closer to 1. I don't even remember which one. Man, it's been a long time. All right, so let's do these questions. So it says, consider the polar equation r equals 8 over 3 plus 5 cosine of theta, or intercepts. So we're going to use what we call the quadrantal angles. You know what I mean by that? So 0, pi over 2, pi, and 3 pi over 2, the ones that are along the axes, okay? Yeah, nice numbers. So let's see. So when I plug in 0, I have 8 over 5 plus, 3 plus 5 times, what's cosine of 0? So see how that works out to be nice? 8 over 8 is 1. All right, how about pi over 2? Well, then I get 8 over 3 plus, and cosine of pi over 2 is 0, so 8 over 3. How about pi? Yeah, I get 8 over 3 minus 5, which is 8 over negative 2. What is 8 over negative 2? Negative 4. And then 3 pi over 2, that's cosine of 0 again, so we're back at 8 over 3. Okay, so we can sketch those points. So we can say, well, along 0, I go out 1 unit. Oh man, my graph is so tiny, it's hard to draw 1 point there. I think my pen's off a little bit. All right, and then I have pi over 2 is 8 thirds. What's 8 thirds? Like a decimal approximation. It's 2 and 2 thirds, so 2.6 somewhere. So 2.6. And then I have negative 4 along the pi line. What happens when it's negative 4? It goes towards 0, right? 4 units towards 0. And then 8 over 3 along the 3 pi over 2 line. So 2. Okay, so right now just seeing those points, it's kind of a little bit like, I don't know what shape this is, right? It looks a little weird. Any guesses? An ellipse? Hyperbola? I don't know. What do we think? So let's see. So we're going to find the eccentricity. So our eccentricity, as you guys can see, is found by E is equal to absolute value of B over A. So when I refer to B and A, these are numbers that are in our original equation, right? So look at the A and the B. Do you guys see where they are? So we're going to compare those. So we're going to take the 5 and we're going to divide by 3. Is that bigger than 1, smaller than 1, equal to 1? It's larger than 1. So as we look at here, eccentricity is greater than 1 means that the graph is a hyperbola. So now that we know it's a hyperbola, are we kind of seeing where it's going to go? So show algebraically that the graph is a hyperbola by transforming into rectangular form. So we can change this into rectangular form. So we can take our r equals 8 over 5 plus 8 cosine theta. And we can multiply that denominator over. So we get 5r plus 8r cosine theta equals 8. Oh, did I have a 3 plus? Why did I do 5 plus 8? I don't know. I'm just adding things in my head that don't need to be added, right? So we're going to start multiplying over. So I'm going to have 3r plus 5r cosine theta is equal to 8. And remember the section that you just did? So if you see r cosine theta, what is it? X. And then we have r there, so that's going to be the square root of x squared plus y squared. So we're kind of getting there. But it's not really a familiar form. Like, I wouldn't look at that and be like, oh, it's a hyperbola, right? So since we have this square root, we're going to isolate that square root. We're going to get it by itself. So I'm going to have 3 square root of x squared plus y squared equals 8 minus 5x. And it's up to you. Some people like to divide the 3 over to truly isolate that square root, and some people like to just square from here. Okay, if we divide the 3 over and square it, do you see how that 3 is getting squared as well? Yeah, the 3 would also get squared as well if I left it on the other side. Like I would have 9 and then parentheses x squared plus y squared, right? So we're kind of getting there. So we have x squared plus y squared equals, ooh, lots of stuff. We're going to FOIL this out. 8 minus 5x squared all over 9. So we have 9x squared plus 9y squared equals, you guys know how to FOIL that out? You can do it in your head or you can write it off to the side. I told you I always wrote it off to the side when I was in school. So we get 64 minus, we're going to have an outer of 40x and we're going to have an inner of 40x. So it's minus 80x plus 25x squared. Okay, and it's almost there. Do you guys see it? So we're going to get all of our x's together, all of our y's together. So as I get all my x's together, I have negative 16x squared minus 80x. And then I'm going to have plus 9y squared equals 64. Okay, so I know this is a hyperbola right now. Do you guys see that it's a hyperbola? How do you know it's a hyperbola? Yeah, Greta? Yeah, we complete the square, but notice our x squared and our y squared terms. See how they're opposite signs? Yeah. That means it's a hyperbola. If they were both negatives or both positives, it's going to be either a circle or an ellipse. But the fact that they're opposite signs, like, we know that it's going to be a hyperbola. So if we complete the square and we pull out that 16, we're going to have x squared plus 5x, and we're going to have plus 9y squared equals 64. We would get that 25 over 4 number. Ooh, gross. I should have given you nicer numbers for sure. And if I take that negative 16 times 25 over 4, see how the 16 and 4 reduce out? So I'm going to have what? Negative 100? That's what I'm adding to this side. So I end up getting negative 16 parentheses x minus 5 over 2 squared. Yes, it is. Thank you. Plus 9y squared equals negative 36. And then I divide everything through by that negative 36. Okay? And it ends up being a hyperbola. It's not the nicest numbers. You're okay. You got this. So I'm definitely going to have y squared over 4 here equals the 1. This number here is going to be weird. It's going to be, you can leave it as a fraction. It's 36 divided by negative 16. Is that right? So negative, yeah, if I put it on the bottom. So actually 36 divided by 16, which is, I don't know, you can write it as a decimal. I'm fine with that. Basically, we take your 36 divided by 16. Okay. So we said show algebraically that this is a hyperbola the step where I knew it was a hyperbola was right here. If you guys can get it to that and say, oh, I know it's a hyperbola because my signs are different, then you're okay. Does that make sense? All right, so where's the other focus of the hyperbola? So we're not done yet. We got to graph this because we still haven't graphed it. I know that a focus is at the pole. That's how this equation always is. Do you see it? It says the general polar equation of conic sections with one focus at the pole is this. So I have a focus right here. Do you guys remember a hyperbola goes around that focus? Do we see this right here? It's got to go around there. Okay, it's going to be symmetric to that on the other side. So if I was at 1 and 4, I wouldn't call it like an axis of symmetry, but I'm going to be directly like symmetric with that. Okay, so I was here at 1 and 4. That pole was 1 unit away, right? That's the focus. I'm going to be 1 unit to the right here. And any point that I had here is going to be symmetric. So if I have this point, then I'm going to have a point right there that's symmetric to it. Does that make sense? So we know that it's going to look something like this with the other focus at what number? 5, right? Okay, so we said that the pole was one of the focus points. That was like 0, 0. This one we're going to say, we could either plug in pi. Let's use pi. R comma theta. I'm going to put the theta second. So I'm going to say either negative 5 pi, or I could write it as going along the 0 radian line, 5 units. Either way. Does that make sense? I don't care which way you write it. Okay. All right, so here we go. So let's try another one. I won't go through all the completing the square. I know that's the part that made me miserable. Yeah, Greta?
So do we have to write the pole as a focus?
Yeah, that's the other focus.
So it should be 0, 0.
No, we know that that's one of the foci.
Oh.
Foci. All right, so consider the polar equation. R equals 10 over 3 plus 2 sine of theta. So again, the way I'm going to have you guys start these is to use the 4 quadrantal angles. Those are the easy ones, right? So if I have 0, sine of 0 is 0. So what number do I get? 10/3. Do you guys see that? Try it along with me, Cade. You with me? All right, then I'm going to plug in pi over 2. So if I plug in pi over 2, sine of pi over 2 is what? 1. So what do I get for pi over 2? 2, because I have 10 over 5, right? Now if I plug in pi, well again, pi is going to be 0, so I have 10 over 3 again. And then if I plug in 3 pi over 2, I have negative 1, so 3 minus 1, or 3 minus 2 is 1, so 10 over 1 is 10. Really big. So I'm going to have 10/3, which is around like 3.3 repeating, right? So as I start sketching out, I'm going to go out to 3.3 repeating along the 0 line. So somewhere around there. And for pi over 2, I'm going to go up to 2. And for pi, I'm going to go out along it again, that 3.3 repeating. 1, 2, 3.3, somewhere around there. And then 3 pi over 2 is a whopping 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's the very last one. Any guesses? Yeah. A parabola? Not a parabola, actually. Because see, it kind of looks like a parabola here, but then we got this point over here. An ellipse? Probably an ellipse. Probably not a circle based on the shape, right? Because it would have to be like over here, right, for the circle. So I think it is an ellipse. I agree. So let's see if it is an ellipse. So we're going to do that. E is equal to the absolute value of b over a. Remember that? And our a value is 3 and our b value is 2. So now we get something that's less than 1. So what does it say on our chart for less than 1? It says it's an ellipse. So we have an ellipse. Okay, one of the focal points is at the pole. So if I sketch this in, I know that the other focal point has to be kind of the same distance from its vertex. Do you guys see where the vertex is? So I was up 1, 2 units. So my other vertex is down here. I'm going to go in 2 units to get the other focus. Do you guys see it? So it should be at 3 pi over 2 comma 8. That's probably the easiest way to call it, right? 8 units along 3 pi over 2. Yeah. Because I used symmetry. So I knew that this was 2 units away from the vertex. This had to be 2 units away from the other vertex. You see it? So I was at 10, so this has to be at 8. I was at 2, and this was at 0. Because this is always at this equation, when it's set up in this form, that one of the focus points is always at the pole. So you see it, one focus. All right, so now if we're trying to get it into rectangular form, so let's try. So we have r is equal to 10 over 3 plus 2 sine of theta. So we're going to multiply the denominator over. We're going to pull the r out. Well, hang on, no, we're not. Lying. We're going to replace with the square root of x squared plus y squared. Then I'm going to have plus 2y is equal to 10. Isolate. So I have the square root of x squared plus y squared equals 10 minus 2y all over 3. And we square. So we get x squared plus y squared is equal to, and we FOIL it out. So we're going to have 100 minus 40y plus 4y squared all over 9. Oh, guys, this is the grumpiest you've ever been. Like, power through. I told you this is going to be the hardest section. And then we're going to have easy ones again. There's light at the end of the tunnel. This is not the rest of the chapter. All right, so I have 9x squared plus y squared. I used to do rotation of conics. I mean, you don't even know how easy you guys have it. Carmel does rotation of conics, and I do not. I should do it. All right, get everything on one side, so I'm going to subtract the y squared over. I'm going to get the y's together. I'm going to get that number on the other side, and I still have that 9x squared, right? So I have 9x squared plus 5y squared plus 40y equals 100. Okay, tell me why this has to be an ellipse. Greta. There's a plus. Now I could also have a circle, though. How is it not a circle? Yeah, like the a and the b would be different. That's a good way of saying it. So if you try to set it equal to 1, right, and you divide that 100 over, like your a and your b, your denominators are different, right? So it has to be an ellipse. In other words, notice how like the number in front of x squared and y squared, they're the same sign, which makes it an ellipse or circle. But they are not the same number. If they were both like 4 or both 5 or whatever, and when I divided by that 100, they would be the same number on the bottom. Does that make sense? Okay. Yes. Yes, this one's not that bad. I should have done this one first. It'd be much better than the other one. I've gotten you guys grumpy for no reason. Okay, so we're here. So see how we pulled out the 5? The x's don't have like a shift at all. It's just x squared, right? What number do I put in here? 16, because I complete the square. What number does that put on the other side? Not 16. 16 times 5, which is 80. So I'm going to have 9x squared plus 5 parentheses y plus 4 squared equals 180. And now I divide everything through by 180. So I end up getting x squared over the 9 and the 180 reduced to 1 over 20. So 20 on the bottom. The 5 and 180 make 36 on the bottom. So I'm going to have y plus 4 squared. So now we see it's an ellipse. Much prettier than the last one. All right, still doing okay? All right, now if you needed to, if you were like, I don't know what shape this is, and you get stuck, you can always find other values, right? This is just a t-table. You could find other values if you need them. Okay, but what I'm showing you is if you have the quadrantal angles and you at least know what the shape is, you can probably sketch it in, because we know where the focus point is. All right, so consider the polar equation r equals 6 over 1 plus cosine theta. So again, quadrantal angles. So if I plug in 0, I have cosine of 0, which is 1. So 6 over 2 is 3. If I plug in pi over 2, I have cosine of pi over 2 is 0. So I have 6 over 1 is 6. If I plug in pi, it is undefined. Something weird. And if I plug in 3 pi over 2, I get 6. So I'm going to have good. I could not do it in my head for some reason. I was like, wait, what? So I have 0, 3, 1, 2, 3. And then I have pi over 2 comma 6. 1, 2, 3, 4, 5, 6. I don't have anything along the x equals pi line. And then 3 pi over 2, I have also 6. 1, 2, 3, 4, 5, 6. Yeah, I think I'm guessing a parabola. Do you guys see where our focus is? Right there. Yeah.
I was gonna say it opens up like this.
Oh, like to the left? Okay, I thought you were guessing. Okay, yeah, you're right. Couldn't tell with your awesome hand signals there. It does open that way, correct. And this one only has one focus, right? So find the eccentricity to decide the shape of the graph. So we have E is equal to 1 over 1. Yeah, because there's nothing like along here. I mean, there was this one, I guess. I don't know. But that was really more at plugging in 0, I guess. All right, so show algebraically that the graph is a parabola by transforming into rectangular form. So we have 6 over 1 plus cosine theta. We're going to multiply over, so r plus r cosine theta is equal to 6. R is x squared plus y squared plus x is equal to 6. When I subtract that x over and I square it, you'll see that something happens. So as I square it, I get x squared plus y squared is equal to, and I FOIL this out, so I have 36 minus 12x plus x squared. Do you see what's happening? When you subtract x squared, the x squareds all go away. So we get something that only has y squared. So if something only has either y squared or only has x squared, it's a parabola. This is a parabola. All right, so I'm going to have y squared is equal to, now remember how it's always like a 4p something? So let's pull out the negative 12 and write it as x. Well, let me rearrange it first so you can see it. So I'm going to have negative 12x plus 36. So when I pull out a negative 12, I have x minus 3. Do you see how this is set up as like y minus 0 squared equals 4p times? Does that make sense? So if I'm finding the focus, vertex, and directrix, I mean, I already have a lot of this stuff, right? I know that my focus is at the pole. I know my vertex is at that point like 3, 0, right? That's actually 3, 0 in rectangular as well. So if I was finding all these things, I mean, I can do it either way. I could sketch it out using this formula and saying, oh, I'm going to go over 3, 0, and then I'm going to have 4p is equal to negative 12, so p is negative 3. So I'm going to go this way and this way, right? And then remember, through that focus, we would open a total of 12 units, whatever number's here. So we're going to go up 1, 2, 3, 4, 5, 6, down 1, 2, 3, 4, 5, 6. Does that correspond with the drawing that we already have? Yeah, it does, right? Because we had pi over 2, we went towards it 6 units, and 3 pi over 2, we went towards it 6 units as well, right? This is our sketch. This is what we have. So the only thing that we're missing, I think, is the directrix. So our directrix is the horizontal line, or vertical line, I mean. Y is equal to 6. X is equal to 6. Jeez. I need an app. So it says confirm all your graphs above by using the polar and radiant settings on a graphing calculator. So let's kind of talk about some symmetry stuff too as we do this. So get your calculator out. All right, so on our graph, we're going to go to mode. We want radians, and we want it to be in polar coordinates. So polar. And then we're going to go to y equals, and when we do, it says r is equal to stuff. So I'm going to do 6 divided by, and whenever you have a denominator, put that denominator in parentheses. So I'm going to do 1 plus cosine of theta. So theta is the x button. And I hit graph. And I get that. Cool, right? So what if I had changed that to, instead of cosine, I made it sine? You see the difference? Let's talk about symmetry. So cosine, the one we had here, this was symmetric with respect to, sorry, WRT is a math thing. It means with respect to. We shortcut everything in math. I could write an entire paragraph in math symbols. You guys would love it. For all x such that x is greater than 0, there exists a, like there's all these symbols. So I am not going to do that. But WRT I sometimes write, and it means with respect to. So it's symmetric with respect to what axis? Yeah, the x-axis, right? All right, and then the other one was symmetric with respect to the y-axis, the sine, right? So looking at the 10 over 3 plus 2 sine of theta, do you guys see how it's symmetric with respect to the y-axis? Okay, you can check your graph, whoops, by putting in whatever we had, so 10 over 3 plus 2 sine theta. Insert a 2. And you can graph it, and you'll see that you do get this ellipse, right? Now ours doesn't, like on my screen, it kind of looks circular. Do you guys remember how we adjust that? Yeah, if you go to zoom and you do square, it's going to make all of those units like square units, and it will look more elongated like we have. Okay? Easy enough? You get it? All right, so I'm going to pass out your homework. Try your best. I know it's not very fun.